In this video, I will be showing how to use Amazon Recognition to recognize facials and objects. We will be using a few components for this project. NodeJs will be used to create an application, Amazon S3 will be used to store the images, VS Code will be used to edit code, and Amazon Recognition will be used to process and analyze the images uploaded. It's important to note that Amazon Recognition is a managed service, meaning that its infrastructure is automated, making it easier to use. As the user, I created a Node.js application on my laptop that will run on localhost port 8089. The Node.js application has a few methods defined for each of the HTML input boxes you see on my web page. When I enter in data in one of the boxes and click submit, it will basically make a post request and store my bucket name and object name in variables. It will call a Rekognition API that is mapped to the post request and pass the bucket name and object name to the Rekognition service. Then Rekognition will process the data and return results, and this can be through labels or probability scores, and it's Rekognition API specific. When using AWS's console, it's important to know the cost of each service and how much you can get on a free tier. So for Rekognition, you can process up to 5,000 images per month. For me, I processed only 6 images, which came out to $0. And once it passes that 5,000 images in a month, then that's when you'll see that you'll be charged. Being that I'm still on the free tier option, I don't have to pay, so my total came out to $0. Now I'm going to do a quick code walkthrough just to get the gist of how the code will be set up in this project. So detect labels is a method that basically labels the objects, concepts, scenes, and actions in images. In this case, detect labels calls a JavaScript post method, and that is tied to a Rekognition API called label detection. There are 2 variables in this function. One variable is bucket name, which stores the bucket name that I specify in the front end, and then the second variable is object name, where I'll also store the image file that I specify in the front end. The function will call Rekognition and pass it the bucket name and object name to the respective API. Creating a Amazon S3 bucket is a very important part of this project. And for mine, I named it Amazon Recognition Project. Inside of the bucket are just JPEG files that I will use to test in my front-end application using Rekognition. And it's important to note that this is just a regular bucket. There's no extra configurations needed. And the instructions on how to create the bucket will be uploaded to my GitHub repository with this project. For Amazon Rekognition, it's very important to note that there are different APIs. The APIs I decided to use are label detection, image properties, image moderation, facial analysis, celebrity recognition, facial comparisons, text and image, and personal protective equipment detection. So there are many more APIs that you can use. Those are just the ones I chose, and this is a link to all the APIs that you can use in Rekognition, and I will have that also linked in my GitHub repository for this project. Now we're going to test the APIs. To test it, first I'm going to go to Amazon S3 and copy my bucket name, and I'm going to paste it in bucket name. Then I'm going to go back and copy the object detection, which is the same as label detection. And I'm going to paste in object name. Before I press submit, I'm going to show you the JPEG that I'm using. As you can see, it's a city with posters and cars and people. Now I have the probability, as shown on this side, of the advertisement, urban, city, architecture, the building, the cityscape, people, cars, transportation, and vehicles, and these are all shown in the picture. And this is what was detected. So I'm going to go back. Now for image moderation, I'm going to do the same thing. I'm going to copy the bucket name and paste it. And then the object name will be a crime scene. Once again, image moderation is testing for violence or explicit content. This is the picture I'm using. It's a crime scene with a knife and blood. And I'm going to press the image moderation button. And we have the probability of the weapons and violence shown in the picture. I'm going to go back. And for facial analysis, we're going to copy the bucket name once again and paste it. And then I'm going to use the facial analysis JPEG. This is the image being used. This is a random person that I pulled this picture off of Google. So it'll be testing his facial attributes. And here are the outputs of his facial attributes. As you can see, it says that he's happy because he's smiling slightly and he's a male. And he's roughly around 30 years old. Okay, then we're gonna go back. Then celebrity recognition, once again, we're gonna copy the bucket name. Then for the object, have a picture of Sylvester Stallone. I'm going to paste that. And it shows his name, Sylvester Stallone, as a 99% accuracy probability that is him. And this is the website that the image was pulled from. For text and image, I'm going to copy the bucket name once again. Then copy the JPEG, which is text image JPEG. I'm going to test it. Let me just show you the image that I used. It says success is not final, failure is not fatal. It's the courage to continue that counts. Winston Churchill. So this should pull out all the words that are in this image. And as you can see, it did. It has the success is not final. The line, failure is not fatal, it's the courage to continue that counts. And then we have the Winston Churchill. Then it breaks down each word that is shown in this image, and it has the probabilities next to it. Close that. And I'm going to go back. And lastly, we're going to do a facial comparison. We're going to copy the bucket name, paste it, and we're going to compare two different images. So the first image is a facial comparison of Taylor Swift, and there's another comparison of also Taylor Swift, and we just want to see if they show up as the same person or not in this facial comparison. So for face 1, we're going to use the facial base JPEG. In face 2, we're going to use the facial comparison JPEG. And it's a 99.96 probability that that's the same exact person in the comparison. All the code for my project will be linked in my GitHub account repository, so you will be able to refer back to that with all the links and code needed for this project. Thank you for watching.